Okay, so write this down. The school has 90 books for 15 students. Okay, how many books did each student receive? So if you look at the question, just the question, this is called the word problem. The question is the sentence with the question mark, right? In the question itself, you read it as how many books does each student receive? So you see how there's an S right there? Each, how many books? And then each means one. Student, do you see how there's no S on student? So how many books? There's an S on books. Books. So where there is an S, whichever word is whichever word is plural, that is going to be your Y. Which word is singular, meaning not plural, that's going to be your X. Okay? So that's how we determine which one's your Y, which one's your X. In the question, it's how many books does each student receive? So the word that is plural in your question is your Y, and the word that is singular is your X. Okay? Because when you divide, your X goes outside and your Y goes inside. So my X is student. So this is students and inside is books. So therefore 90 goes inside and 15 goes outside. You might be sitting there going like, wow, that's a really complicated way, Miss O'Malley, to tell me how to divide. I already knew what number to go inside. I already knew that how to set it up, Miss O'Malley. Like, cool. That's not why I told you. I told you because when you do your table, do you know what to write next to X and do you know what to write next to Y? Don't be stubborn now. You guys need to know what's X and what's Y because that's where a lot of students miss the points and make mistakes because they don't label the X and Y correctly. And that comes from from knowing plural and singular. All right. So, guys, what's 90 divided by 6? 90 divided by 15. Yay, I got answers. 6. Now, 6, what? 6, what does 6 represent? 6 students or 6 books? 6 students or 6 books? Ooh, I got both answers in the chat. Students and books. Read the question. Read the question. What are you solving for? Read the question. What are you solving for? Just read the question, not the word problem. The question. Yeah. When in doubt of like, what am I solving for? Read the question. The question will go like, how many books does each student receive? Oh, how many books? Oh, 6. That's how many books? 6. Now, you guys, I mean, some of you went public on your responses. So you guys see, we went everywhere, right? All like half the class who responded went books, half the class who responded were students. And that's fine. That's fine to tell me and make mistakes. It's fine because you're gonna go like, oh, okay, I get it now. Instead of staying quiet or ignoring me, if you were participating, your brain goes like, oh, cool, we got it right. Or, oh, yeah, that's right. It is books, not students. Okay, cool. Yeah, I get it now. So participation is awesome. That is what we call constant proportionality. So 6 books. Constant proportionality is 6 books. You want to add per student, you can. Okay, 6 books per student. So if you're like, what did I just solve for? And a lot of times it's that when you're doing a word problem, you know what you're doing. You're like, okay, I got to divide. That's cool. But what does your answer mean? What does your answer mean? Oh, I don't know. I just solved it. It's like, cool. Now you're in a math 7th and beyond that you have to explain what your answer means. All right. So X is students. Y is books, right? And I've been telling you, if you create your own table, Just do 0, 1, 2, 3, maybe a 4. You know, however big your table is. Don't get all complicated, kids. Just do 0 through 4, okay? Just simple. All right. So if I have 0 students, how many books do I pass out if I have 0 students? 0, right? If I have 1 student, how many books does 1 student get? 6. That's what you solved for. 2 students? 12. 3 students? If I can count correctly, right? What you should notice is this is why I want you to do a table that's 0, 1, 2, 3, 4. Right? This is why I want you to do this. Why? Because all you're doing here is adding by 6, right? Right? That's why I want you to do 0 through 4, because it's easy, right? Now, what is your equation? This is what I showed you yesterday. What's your equation? What would be the equation of this problem? Give you a clue. It starts with the Y. Yes. All right. 1 student. I love it. Yes, 2 students. I love it. Y equals 6x. That is your equation. It's always y equals the number of constant of proportionality and then an x. Y equals 6x. 6 times x. What is x? It's students. So if I multiply 6 times the number of students, I will get how many books they get. So what if I skip over and I say, okay, kids, I have 30 students. 30 students. How many books does 30 students get? How many books does 30 students get? How many books does 30 students get? I'm going to write that down. How many books do 30 students receive? Yep, good. 180. How do we get 180? Did you multiply y equals 6 times 30? Maybe you didn't realize you were doing this. What you were doing is just multiplying 6 times 30, because 30 is students, and you get 180. So 180 books, right? All right, that could be a question I ask you on a test, right? All right, so first thing you do, divide. Second thing you do, you write the constant of proportionality. Thank you. The third thing you do is you create a table. The fourth thing you do is you write an equation. The fifth thing you do is answer some questions. These are not the only questions I got to ask you, but we're good right here for now. I don't want to get all complicated like I did yesterday. All right, now the sixth thing I got to teach you is how to graph this. If you're using graph paper, awesome. If you're using line paper, awesome. Obviously, graph paper is going to be easier than line paper, but line paper, you can still do it. It's not going to be as pretty, but do it. Okay. I'm going to teach you the easiest way to graph this. Are there other ways? Oh, 100%. Is it more complicated? Yes. We're not in the business of complicating things, okay? It's bad enough I teach math. It's already complicated. All right. Here's how you're going to do the graph. Let me do it first, and then you can do as I. Okay. So in 7th grade math, we just need what is called quadrant one. We just need this space. Have you guys ever graphed on a coordinate plane? Have you guys ever done like the dots and then connected it and then made a picture? Did you guys ever do that in 6th grade or elementary school? Like connect dots, make a picture? Yes, okay, good. Well, one of you did. I don't know about the rest of you. All right, so we're gonna graph, okay, kids? If you've never graphed in your life, well, I guess today's the day you get to graph. If you have graphed, this does become a lot easier for you. Okay, we're good? Okay, cool. So did you draw this line? Okay, now, this line, the horizontal line represents your X. The vertical line represents your Y. Okay, this represents your X. This represents your Y. Okay? Your table is, so X represents, let me go back. X represents students. So these numbers represent students, and the numbers going up and down represents books, right? So this line represents students, and this line going up represents books. All right. If you out there, if you are the one creating the graph, if you're the one creating the graph, like we are right now, this is what I want you to do. On your X, if you are the one creating this, if here, you're going to make this, so where you draw your line, that's 0, okay? The next line over is 1. Next line over is 2, 3, 4, 5, 6. Now, notice, zoom it in right there. Notice that I put the numbers on top of the lines. I don't put them in the boxes. Do not put the numbers in the boxes. You are numbering the lines, not the boxes. Okay, so if they never taught you this, I guess I'm the one teaching it to you. Number the lines. Notice that the numbers are on top of the lines. Yes, it makes a difference. Trust me. When kids number boxes, they don't get the correct graph. So learn from me. So line paper, I can't be picky. We're in distance learning. If you were in the classroom, you would be using graph paper. If you're using line paper, it's not going to be pretty. But if you're using line paper, you're doing like, you have your graph, right? Look, it's not even pretty right now. Then you would be doing dash 1, 2, 3, 4, 5. That's how you would do it on line paper. You would be recreating that. Yes, of course. You can add, if you have graph paper that's over here and you're like, oh, but I'm using line paper. What you could do is take graph paper, do the graph, and then just glue it in here. Oh my God, yes. So if you have a line paper, 100%, cut out a little piece, this big, glue it in here. Brilliant. If you have line paper, then you're kind of doing the little dashes, little tick marks. We're making it work, kids. It's distant learning. Some of you have graph notebooks, some of you do not. It is what it is. If I can hand you graph paper right now, I would, but I can't. Technology's not there yet. Okay, so why did I go 1, 2, 3, 4, 5, 6 on X? Why? Because the numbers here are 0, 1, 2, 3, 4, 5, 6, right? Or I didn't go all the way to 6, but these are these numbers here. Okay? Now, if you are creating your graph, this is only when you create your graph. If I give you a graph that's already pre-made, then it doesn't really work. You got to work with what you have. But here you have it. If you want to be cool and not work hard, but work smart, we're going to work smart right now. When you do your Y's and you number your Y's, do not go up by 1. Don't go 1, 2, 3. No. That's working harder. Let's work smarter. On your Y's, you're going to go up by your constant of proportionality. On your Y's, go up by your constant of proportionality, and you're going to thank me later. So my constant of proportionality is 6. So I'm going to go 6, 12, 18, 24, 30, 36, 42, 48. I'll stop there. So I'll zoom it in. So what I did on my Y's is I went up by my unit rate. It's a little secret. You work smarter, not harder. If you graph, like when you do those graphs with the pictures and, oh, so cool, yay, I created a giraffe. They go up by ones, right? They go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and they go up by ones here. Cool? Yeah, we're not drawing little pictures. We're doing math here. So go up by your unit rate. Go up by your unit rate. On the X, go up by ones. On the Y's, go up by your unit rate. Trust me. Let me show you a picture of what I mean. Hold on. Okay, now we have our graph set up. Now let's actually graph. Okay, what you don't know, but I know, what you know, is that these are your ordered pairs. How many, do you guys remember graphing like ordered pairs? They look like this. You guys remember these? They used to create the picture in like 6th grade. Yeah, it was fun times, huh? Fun time. Life was so good back then. Or even maybe elementary school. Okay, well, where did I get this? Literally, I got it from your table. It was fun when you were made. Yeah. So these are these. You see 0, 0, 1, 6, 2, 12, 3, 18, 4, 12. So you get your ordered pair. These are called ordered pair. They're in the form of X, comma, Y. The first number represents X. The second number represents Y. So I got these from your table. That's why we create a table, because you graph what's on the table. What? Okay, so here's our first point, 0, 0. That would be right here. That's your first point, 0, 0. It's called the origin, 0, 0. Okay, my next point is, so I did that one, 1, 6. So 1 means I go to the right 1, and then I go up to 6. Next point, 2, 12. 2, up to 12. 3, 18. 3, 18. 4, 24. What would 5 be? 5 would be 30. 6 would be 36. Do you guys see the pattern? What are we always going up by? 6. Now, you connect with the straight edge, a ruler, an ID card, a pencil. Connect in a straight line. All your dots connect. If you have 2 pencils or a pencil and a pen, it works. You use this as your straight edge. It's a little harder, but you can use, like, this is another pen. This is one pen. Just draw it straight up, just like that. Okay? Now, why did I have you go up by your unit rate? Because if you didn't go up by your unit rate, let's say you went up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? It would be, your first dot would be 0, 0, and then 1, 6, 2, 12. You see how, like, it still represents the same. It still represents a straight line, but like your dots are like super spread out, and it's like, why? Wait, we don't need that. We just don't need that. There's just no need for that, kids. Just no need. I mean, in my opinion, there's just no need. All right, are we good? So it's more work, exactly. And here it's really easy to graph. You just go 1 up, 1 over 1 up 1, over 1 up 1. But you're really going up by 6. This is if you create the graph. If I give you one that's like goes by ones, then your dots are going to be like spread out, but you're still going to create a straight line. All right, how do we feel about this? Are we okay? So the new part today is just the graph. It looks like a lot, but the new thing that I taught you was just this part. This is the only thing new today. Hopefully it's easy. All right, go back to Monday's notes. The first problem we did on Monday. Oh, Miss O'Malley, I don't have those notes. Well, get working. Hurry up, copy it. Let's go. Ándale. Fast. Let's go. Okay. We already have everything here. We have the equation, table, unit rate. Cool. Let's graph it. Let's practice graphing it. So we're going to create your coordinate plane. I just need quadrant 1. Okay. When you do a coordinate plane, you always label X, and Y. You don't actually label what it is. You don't tell me like X represents this, Y represents that. That's only in your table that you tell me like, okay, X represents this, Y represents this. All right, we're good? Okay. X. X actually represents bags of chips. So we have 0 bags of chips, which is this line. 1, 2, 3, 4, 5, 6, 7, 8, whatever. However many you want to do. Okay, so again, let me zoom it in. We're on our very first problem that we did on Monday, which is the bag of chips. We're going back to it and adding the graphs. Today, for your picture, I want to see those graphs on the bags of chips. Okay, now, what am I going to count up by on your Y? What am I going to count up by? Yeah, if you're making the graph, go up by your unit rate, please. So it would be 1.4, 2.8, 4.2, 5.6. I got that from the table. Like if you look, since we did it in order, since we were smart, I set you up to be, amazing. Since we did 0, 1, 2, 3, 4, we just use these numbers to create this. And it's like, oh darn, I didn't go too much. I didn't do the next number. Okay, quickly, I'm gonna do it in my head. Okay, 5.6 plus 1.4, that's a 0, carry the 1. So that's 7. 7 plus 1.4, that's 8.4. That's 8, 9.8. Right? So here we're going counting up by 1.4, right? We're counting up by 1.4. Why? Because it's your unit rate. And we don't want to work harder. We want to work smarter. Okay, cool. Now we are going to plot the points. Here are my points. 0, 0, 1, 1.4, 2, 2.8, 3, 4.2, right? Imagine your graph would look like this. So then you would be graphing 1.4. Gosh, I think it's like right here. Yeah, 1.4. And then my second number would be 2.8. 2, yeah, I want to guess it's here. 2.8, maybe like right there. So if we count by ones and you're dealing with decimals, you're kind of guessing where your dot is. Not very accurate, right? And in math, we like accuracy. So this way, I'm just, hammering it in why you need to go up by your unit rate if you're the one creating the graphs. And guess what? You are. So there you go. So first point, 0, 0, which goes right there where the two lines cross. Boom. 1, 1.4. 2, 2.8. 3, 4.2. 4, 5.6. Gee, let me show off my math skills. Let me be super smart in front of you. 5 would be 7. 6 would be 8.4. 7 would be 9.8. Did you guys like how fast I did that? I know I impressed you by how fast I figured out what 5, 6, 7, and 8 would be without having it on my table. I know. I sometimes, show off. See, now this is learning. I don't realize if you can catch my sarcasm or not. Paula, thank you for, yeah. But I'm really not showing how smart I am, or lack thereof. It's just because I know that the dots will go in order and they go up 1 over 1, up 1 over 1, up 1 over. Why do they do that? Because of how we set up our graphs. If you don't set them up this way, dude, so much harder. So much harder for you. We okay? We okay? So far, so good? Okay. Again, today what we're doing is we're doing the graph. Yesterday we did equations, so we're building upon it. And I'm still not done. These problems have a lot of stuff to them. That's why it's the most important thing in 7th grade. All right. The next one we did was a box of cereal. So can you start off the graph without me? So start it off without me. What do you label your X? What do you label your Y? And what do you graph it with? Start it off without me. So here we have our graph. X and Y, this is Y. Y we went up by 2s because 2s are unit rate, so 2, 4, 6, 8. We plug them in, okay? Your graph, if it's proportional, will start at 0, 0 and be a straight line, okay? 0, 0 and be a straight line, that means it's proportional, okay? All right, we have one more. We have one more graph to do, right? We have to graph this one. The cost of 6 pounds is $2.40. So what was our unit rate? Our unit rate was 40 cents. Our unit rate was 40 cents. So let's start that graph. So this is X, this is Y. X will always be 1, 2, 3, 4, 5, 6. Remember, you're doing them on the line. My Y is my unit rate, my constant of proportionality, which is 40 cents. 0.4, 0.8. The first dot is 0, 0. Do not forget 0, 0. It's actually a very, very important dot. 1, 4, 2, 8, 3, 120, 4, 5, 6. I'm going to connect the dots. Okay. All right. Any questions on this? Now, later on, or right now, I can ask you questions from the graph. Like if I were to do 7, the question might be, how much does 7 pounds cost? How much does 7 pounds cost? And you're like, oh, 7 pounds. Oh, it's not on my table. Let me look at my graph. Okay, here is pounds, right? X represents pounds. Okay, so 7, go up to 7, then I go over, 2.8, because this represents pounds. So I guess I should have had you label it. 7, no, this is money. Oh my gosh, I'm losing it, kids. I'm losing it. So, 7 pounds cost $2.80. How do I know it's $2.80? Because it's on my graph. So your graph also allows you to answer questions, right? So you can answer it using the table, you can answer it using your equation, you can answer it using your graph, and they're all related. But if you label your X and Y wrong, everything's wrong. Imagine if I made this money. Okay, $1 is 0.4 pounds. No, it's the other way around. So the first part of recognizing what's your X and Y has an impact all the way through the whole problem. So be careful, be careful, be careful.